Good evening, good afternoon, or good morning, depending on where you are in the world. We'd like to present to you 3 articles of interest. Before I do that, I would like to let you know that this is for review, informational, and educational purposes. It is not to take the credit for the intellectual property of the article. The full credit to the intellectual property of the article goes to the publisher, which in this case is Daily Galaxy, and the story by Samir Sabati. Headline reads, Airbus and Toshiba collaborate on revolutionary superconducting aircraft motor technology. Ahead of you is a picture of this motor, looks like, and you can see the propeller, the engine, all the different parts, including the frame. Caption reads, Airbus and Toshiba collaborate on revolutionary superconducting aircraft motor technology. Copyright Daily Galaxy. Now to the article itself. As I make this a little louder, there we go. Superconductivity is a phenomenon that occurs when certain materials are cooled to extremely low temperatures, causing their electrical resistance to drop to nearly zero. The property allows the creation of powerful and efficient magnets, which can be utilized in various applications, including medical image or CAT scanners, particle accelerators, power transmission networks, and electric motors. In the context of aviation, superconducting motors offer significant advantages over conventional systems. Airbus claims that the superconducting motor is over 3 times lighter than traditional alternatives and boasts an impressive 97% powertrain efficiency rating. This remarkable improvement in power-to-weight ratio makes superconducting motors an attractive option for aircraft propulsion. The collaboration between Airbus and Toshiba brings together 2 industry leaders with extensive experience in their respective fields. Airbus, through its subsidiary Airbus Up, Next has been exploring innovative propulsion technologies, while Toshiba's energy arm, Toshiba Energy Systems and Solutions Corporation, has been developing superconducting motor prototypes for over half a century. In a related video entitled Airbus CEO Follery on Supply Bottlenecks, Costs, and Deliveries as per Bloomberg. And this will be available upon publishing of this review, but only on Rumble, as YouTube does block links that are in the comment section that refer back to another website, such as this article. And now back to the article itself. Hydrogen-powered aircraft, a sustainable future. Development of this superconducting motor is closely tied to a broader goal of creating emissions-free aircraft. Among the various options for achieving this objective, hydrogen stands out as the most promising solution. Hydrogen offers relatively high density and produces minimal emissions, with water vapor being the primary byproduct. However, the use of hydrogen in aviation presents several challenges. The first one is storage, which is that hydrogen requires significant volume compared to traditional aviation fuel. The handling, practical use necessitates storing hydrogen as a cryogenic liquid in temperatures below minus 253 degrees Celsius, that is minus 423 degrees Fahrenheit. Weight. Conventional electric motors, powerful enough for aircraft propulsion, are typically very heavy. The innovative approach proposed by Airbus and Toshiba addresses these challenges by utilizing the liquid hydrogen as both fuel and coolant. The dual-purpose solution allows for the creation of more compact and efficient propulsion systems. Synergy of technologies. Cryoprop and superconducting motors. The partnership between Airbus and Toshiba, officially signed at Japan Aerospace 2024, combines 2 key technological improvements. By integrating these technologies, the companies aim to create a breakthrough propulsion system that could redefine excuse me, they could redefine aircraft design possibilities. The liquid hydrogen used to power the fuel cells will first cool the superconducting electric motor before being fed into the fuel cell itself. The ingenious approach maximized the efficiency of the entire system. Gregorich Umbach, the Airbus senior vice president head of disruptive R&T, emphasized the significance of the collaboration, stating, quote, "Partnering with Toshiba presents a unique opportunity to push beyond the limitations of today's partial superconducting and conventional electrical motors." Unquote. He further explained that the partnership is a crucial step in advancing superconducting motor technology to meet the specific needs of the aerospace industry. Implications for future aircraft design. Development of the superconducting motor technology has far-reaching implications for the future of aircraft design. By significantly reducing the weight and size of propulsion system, engineers will have greater flexibility in designing more aerodynamic and efficient aircraft. Some potential benefits of the technology include increased payload capacity, extended flight ranges, reduced fuel consumption, lower operating costs, and decreased environmental impact. As the aviation industry continues to face pressure to reduce its carbon footprint, innovations like Airbus Toshiba superconducting motor could play a crucial role of achieving sustainability goals. The collaborative effort between the two industry giants represents a significant step towards a cleaner, more efficient future for air travel. Excuse me. That will do it for our first article. Let's go to our second article. And before I do that, I would like to let you know that this is for review, informational, and educational purposes. It's not to take the credit for the intellectual property of the article. The full credit to the intellectual property of the article goes to the publisher, which in this case is Organically Human, and the story by Sean Cate. Headline reads, "Scientists make revolutionary breakthrough in air pollution removal without any electricity. Here's how it works." And what you're looking at actually is a slideshow that has an explanation. So we're going to do 8 of the slides, And for the first one, we're looking at said device here. Natural inspiration for air pollution removal. Researchers in the UK have proposed a new method for direct air capture, or DAC, of carbon dioxide inspired by biological processes found in nature. The idea is to mimic how natural membranes transport chemicals passively through a flow from air of high concentration to low concentration. They applied this principle to design a device that can effectively remove carbon dioxide from the air. The natural mechanisms allow the device to work without requiring external energy output, aside from the heat source, to keep certain components molten. Okay. It's a similar, more eco-friendly way of capturing carbon than any current DAC methods. Let's look at our second slide. How the device works, a humidity-driven process. The core of the new technology lies in its innovative membrane design. The researchers create a membrane by drilling conical holes into the alumina tube and filling it with molten carbonate salt. The trick? Using a difference in humidity. The input of the steam is dry while the output of the steam is wet, causing carbon dioxide to flow spontaneously towards the output. Quote, "The surprising thing about the membrane is how rapid the permeation process is," says Ian Metcalf, professor of chemical engineering at Newcastle University. "This process is much faster than expected, thanks to water helping release the carbon dioxide from the carrier in the membrane." Let's go to our third slide. Not the commercial, there we go. A game changer, no electricity required. Most current DAC methods require significant amounts of energy to concentrate carbon dioxide from the atmosphere, but not this one. The only energy in this new process is to keep the carbonate salts molten at temperatures of over 400 degrees Celsius or 752 degrees Fahrenheit. While this does require some heat input, it eliminates the need for electricity, which means it's eco-friendly from alternative to existing technologies. As Metcalf explains, quote, you would also need a large heat exchanger and some heat input to process the air. But what we would like to do now is to drop the temperature of operation. Quote, reducing the temperature is the next challenge for researchers aim to tackle. Let's go to our fourth one here. Addressing the climate change head-on. The breakthrough is particularly important as we face rising levels of carbon dioxide in the atmosphere, which only accounts for 0.04% of air, but also significant impact of global warming, as they put it. Current DA systems are energy intensive, which negate some of the environmental benefits, but this new method promises a less energy hungry solution. By helping capture carbon dioxide efficiently and without large energy demands, the device could complement the Earth's natural carbon cycle and make a major dent in the greenhouse gas levels. Let's go to number 5 out of 8. The bigger picture, government support and future development. The breakthrough fits into the broader effort to tackle climate change on a global scale, that is. Governments worldwide, including the US, are investing in carbon capture technologies. As of January, the US has 15 operating carbon capture, utilization, and storage CCUS facilities, within 121 additional projects and developments that could remove 3% of the nation's annual carbon pollution if completed. Additionally, the U.S. government has allocated $3.5 billion in funding from its Regional Direct Air Capture Hubs program, which will demonstrate the new DAC technologies on a commercial scale. These hubs aim to remove 1 million metric tons of carbon annually, and breakthroughs like its new device could significantly accelerate the effort. Let's go to the 6th one, and minus the commercial there. Innovative collaboration for clean energy. Many companies, including General Electric or GE, are working on developing new carbon capture solutions, while others are exploring the use of natural heat sources like geothermal energy to power DAC systems. These collaborations are not just about cleaning the air, but also creating good-paying jobs in the clean energy sector, making the field an exciting area of growth and opportunity. Incorporating innovations like the electricity-free DAC device would further boost efforts to reduce global carbon emissions and air pollution. Let's talk about the 7th one. Looking ahead, what's next for technology? Well, the new DAC device is a promising development. Researchers are already thinking ahead. The primary focus now is on lowering the operational temperature to make the process even more efficient and scalable. Achieving this goal would make the device more accessible for large-scale industrial use, accelerating its adoption in the fight against climate change. By refining this system, the team hopes to create a more affordable and effective way to to capture carbon dioxide on a global scale. Definitely don't want to create it, we want to capture it. And for our last slide, a major step toward cleaner air. The new direct air capture device makes a breakthrough in carbon capture technology, offering a solution that works without electricity and mimics nature's processes. With the potential to complement the Earth's natural carbon cycle and significantly reduce air pollution, the innovation could help get our environment back on track. The future of clean air may be closer than we think, thanks to these exciting new developments. All right, and it says, read more: the future of ocean transportation, Japan testing clean energy, biomethane-powered ships. And our sources are: number 1, scientists make revolutionary breakthrough in air pollution removal without any energy. Here's how it works. As per the cool down, John Turry, August 29, 2024. And our second source